Hello, I am SAPTASHWA BHATTACHARJEE, roll number 21EC10064.
Hello everyone, my name is Akshra Shukla. My roll number is 21EX10005.
Hello, I am Shubhangi Singh, roll number 21 CE 10065.
Hello, my name is Mohammed Shijaz. My roll number is 21ME 30046.
Hello, I am Nathaji. My roll number is 21IA 10029.
Pulse oximeter is a device that measures the oxygen saturation level of our blood. In addition to that, we can also measure our heartbeat rate. It can rapidly detect even small changes in oxygen levels. These levels show how efficiently oxygen is being carried to the extremities farthest from our heart, including our arms and legs. Abnormalities in the readings are indicative of several diseases.
The components used in the making of pulse oximeter are Arduino Mega, LCD I2C, MAX 30100, breadboard, male to female jumper wires, and male to male jumper wires. This is the circuit diagram for our project. The components shown here are Arduino Mega, LCD I2C, MAX 30100. The VIN of MAX 30100 and LCD I2C is connected to 5 volt of Arduino Mega. The ground of both of these devices is connected to the ground of Arduino. The SCL of MAX 30100 and LCD I2C monitor is connected to the SCL of Arduino Mega, and the SDA of MAX 30100 and LCD I2C is connected to the SDA of Arduino Mega.
I am Nathaji. Now I am going to tell about MAX 30100 and its functioning. It is a pulse oximeter and heart rate sensor. It consists of high intensity LEDs, a photodetector, and low noise analog signal processing to detect pulse oximetry and heart rate signals. The wavelength of LEDs are 660 nanometers and 880 nanometers. The It works by shining both lights onto the finger and measuring the amount of reflected light using a photodetector. The it works Working of it is divided into two parts: heart rate measurement and pulse oximetry. As the blood is pumped through the finger with each heartbeat, the amount of reflected light changes, creating a changing waveform at the output of the photodetector. As you continue to shine light and take photodetector reading, we get the heartbeat pulse reading. Pulse oximetry is based on the principle that the amount of red and infrared light absorbed varies depending on the amount of oxygen in our blood. The ratio of infrared and red light received by the photodetector. By measuring the ratio, the oxygen level in the blood is calculated.
Hash include a liquid crystal underscore I2C dot H. This library allows you to control I2C displays with functions. I2C is a serial communication protocol, so data is transferred bit by bit along a single wire, the SDA line. So SDA line is serial data line, the line for the master and slave to send and receive data, while SCL is the serial clock, the line that carries the clock signal. Then second liquid crystal underscore I2C LCD 0 cross 27, 16, 2. It is used to declare a liquid crystal underscore I2C object with I2C address, the number of columns, the number of rows. The LCD can print data in 16 column and 2 rows. Then void setup serial.begin 9600. This is used to print in the Arduino IDE, whereas LCD.begin 16,2 initializes the interface of LCD screen and specifies its width and height. Delay 3000. So then serial.print initializing pulse oximeter prints on the Arduino IDE. So here initialize sensor if p not pox dot begin. This is used to print failed if the connection fails, and it prints success in the other case. Then next part of code, the backlight part. This is used in small displays to increase the readability in low light conditions. Using this function helps us to turn on the backlight. Then LCD set cursor 0, 0 sets the cursor to the beginning. LCD dot print BPM prints the words BPM, while LCD dot print POX dot get heart rate prints the BPM data. LCD dot set cursor 0, 1 sets the cursor to the next line, and LCD dot print SPO2 prints the words SPO2, while POX dot get SPO2 prints the SPO2 data. LCD dot print percent prints percentage symbol, and at last LCD.
Here we have included the max30100 underscore pulse oximeter.h library. We have also initialized an object named POX of the type pulse oximeter. We have initialized a variable TS last report with the value 0, whose data type is uint 32 underscore t. This ensures that the value of this variable is essentially a 32-bit number. We have also defined a constant reporting period underscore ms, whose value is set to 1000, that is 1000 millisecond, which is equal to 1 second. The use of this constant is that it ensures that the pulse oximeter takes readings after every 1 second. Here we have used an if-else conditional construct which checks whether the connections are proper or not. If the connections are not proper, it will print failed on the serial monitor and it will try for fixing the connection. However, if the connections are proper, it will print success on the serial monitor and the code proceeds. Here is the if conditional construct. This logic checks that whether the time gap between two successive readings is more than 1 second. If it is more than 1 second, then this part of the code gets executed. The get heart rate function helps us to print the heart rate, and the get SPO2 function helps us to print the SPO2 level on the LCD screen in percentage. And here is the update expression for the value of TS last report using the help of the inbuilt function millis.
We used Arduino Mega 2560 for this project. From this, 4 wires are connected to the breadboard: 5V pin, ground pin, SCL and SDA pin. This is a max30100 pulse oximeter used. From the breadboard, the 4 wires are connected to the sensor, and to display the readings from the pulse oximeter, we used a LCD display. From the breadboard, 4 wires are connected to the LCD display also.